Okay, so for this one, what we're trying to do is if they have the same base, then basically I can say that the exponents have to be equal to each other. All right, so I look at it and I see 5 and I see 25. And so I say, okay, 25 can be expressed as 5 being 5 squared, right? 25 is just 5 squared, correct? So I'm going to rewrite this equation just using 5 squared. So I have 5 to the 3x minus 1 equals 5 squared, because that's just 25. All right, so doesn't this line of logic make sense? That because 5 to the 3x minus 1 equals 5 to the 2, then since these are the same bases and they are equal to each other, these expressions are equal, then this has to equal this. So I get 3x minus 1 equals 2. And I go ahead and solve that. And I add 1 to both sides. 3x equals 3. Divide both sides by 3, and x equals 1. Just like my answer has. All right, same thing for the next one. Okay, so now I look at my bases, and I look at 9, and I look at 81, and I think, okay, since 81 is a larger number, I think, can 81 be expressed in some power with 9? And so I say, okay, yes, it can be, because 81 just equals 9 squared. So I just am going to write 9 to the x plus 6 equals 9 squared, because that's 81, x minus 2. Okay? So I am going to have to, I see I have the same basis, so I'm already set. So now I have x plus 6 equals 2x minus 2. So if I solve that, I get x plus 6 equals 2x minus 4 by distributing. And I have x plus 6, let's write it out again up here. So I'm going to add 4 to both sides, where I have x plus 10 equals 2x. Subtract x, and I get x equals 10. All right? And I get the same thing. Okay, next one here. Now I have 5 to the 4x times 5 to the 12x equals 625. All right, so I'm going to use 625, and I'm going to try to get at the same basis as a 5. So I think of, okay, 5 times 5 is 25, times 5 again is 125, times 5 again is 625. So 625 is just 5 to the 4th. So I'm going to rewrite this as 5 to the 4x times 5 to the 12x equals 5 to the 4th power. All right, so when I'm multiplying two things that have the same bases, then the two exponents get added. So that's going to be written out like this: 5 to the 4x plus 12x equals 5 to the 4th. All right, so now I can go ahead and add them, and I get 5 to the 16x equals 5 to the 4th. The bases are the same, so 16x equals 4. Divide by 16, and that is going to be 1/4. Okay, number 5. So solve by the method of your choice. All right, so I'm going to look and see, you have a couple choices. You can solve with substitution. You can solve with elimination. You can solve with graphing. It's really your choice. I look at this and I think I'm going to choose substitution. The reason I'm going to choose substitution is because y is already all alone and it's already easy, so I'm just going to put negative 2x on this side, and I'm going to create this to y equals negative 2x plus 10. So that's why I chose substitution, because this is already done easily. So in the graphing calculator, it's very simple, and I'll talk to you about that in just a second. Okay, so I'm going to put this into here, and I get 5x minus 2 times negative 2x plus 10 equals 16. Okay, and now I'm just going to solve. So I get 5x minus 2 times negative 2x, which is positive 4x. And this one here is going to be minus 20 equals 16. I'll do a little bit more solving. And I get 5x plus 4x is 9x minus 20 equals 16. Add 20 to both sides. And I get 9x equals 36. Divide by 9, and x is equal to 4. So my x is equal to 4. Now I need to take that 4 and put it back into either equation, either this equation or this equation, to solve for my y. So let's just choose the top equation, and I have 5 times 4 minus 2y equals 16. So I get 20 minus 2y equals 16. And if I subtract 20 from both sides, negative 2y equals negative 4, and divide by negative 2, I get y equals 2. So that's where my answer comes from of here. Solution is 4, 2. So what that means is this is my graph, and at 1, 2, 3, 4, 1, 2, right here, what that means is if I graphed these here, that this is exactly what this would be, is that, let's say 1, I have not looked, oh, excuse me, I can't see anything. I have not graphed, this graph may not be exactly accurate, but I'm just showing you in general what this means. This is 4, 2, and 1 may be like this, and 1 may be, you know, like this or something. So what that means is at 4, 2, that point they intersect, or that 4, 2 is the only point that is on the red line and the black line. So that's what it means. Again, with graphing, you could graph it by hand. The calculators these days have so many different easy ways to graph. You can put these into the graphing calculator. If you need help with how to put it into a graphing calculator, you can email me or you can Google it. It's so many different calculators that you're using, but typically you just put them into some of the TI Inspires and some of the advanced calculators. You can put them in exactly how they are right now. With some of the older calculators, you have to put them into a y equals form, like in this form here, and then you put this part into the graphing calculator. You would have to do the same with this, and then it would graph it for you, and you would find the same intersection that we found. Okay. Again, this one says any method. So this one is an obvious substitution one for me because x is all alone, so I'm just going to take this and put it right in for the x. So I get 2 times 6y plus 3. By the way, this is number 3. Minus 12y equals 6. So I'm going to distribute and solve this. So I have 12y plus 6 minus 12y equals 6. So 12y and 12y, if you notice, those are going to cancel and make 0. 12y minus 12y is 0, and I'm left with 6 equals 6. So let me ask you, in this world, when is 6 equal to 6? Well, of course, the answer is always. So what it's telling you is it doesn't matter what number you put in for here. It's going to bring out a number for y, and it doesn't matter the same thing. That same number is going to also work for y, and if you put another number in for x and you get a number y for y, you can put those again in here. Because essentially, if you graphed these, this is what it is. This is your line 1, and guess what? Your line 2 is right on top of it. So this is just the same line. It's just like calling, it's the same person. If you call your mom, mom, but then your dad calls her sweetheart, sweetheart and mom are the same person. However, they're just expressed a little differently. So same thing, these two are the same line, and that's why they have infinite solutions, because what you're asking for is where do they intersect? Well, obviously the same line is going to intersect in infinite spots. Okay, this one here, solution by our choice. Okay, this one here, I'm going to go ahead and choose a method called elimination because I see the 6x and the 6x line up nicely. Again, you can use substitution again, you can use graphing again, but I'm going to use elimination. The reason I'm going to use elimination again is I think it looks the easiest because when I add these equations together, these 6x's are going to cancel or subtract them. So I'm just going to write them out like this though. 6x, I'm going to subtract y, minus y equals -4. So what I did was I subtracted y from both sides. The reason being is because I want this to be lined up. I wanted my x and y's all lined up because I'm about to subtract these. So now that I'm going to subtract them, I have to have these x's be completely opposite from one another. So either I have to have positive 6x and negative 6x, or positive y and negative y, something. I have to have something. So I'm going to go ahead and subtract them because they're both positive. So I'm going to, if I subtract them, that changes all the signs to here. And I go 6x minus 6x is 0. Y minus y is 0. -4 minus 2 is -6. So now I have 0 equals -6. And I ask you, when in this world does 0 equal -6? And obviously, hopefully you would say never. So this is never equal to each other. So that's why there's no solutions. And this is what these lines represent. Basically, one line looks like this, and the other line looks like this. Those are called parallel lines. So it's asking where do they intersect, and if they're railroad tracks, hopefully never. You don't want parallel lines to intersect. That would cause a big problem. So that's why there's no solution. Okay. Number 8. This one here now are getting a little bit more complicated because I have 3 equations and 3 unknowns. So you can do this many different ways. You can do substitution, you can do elimination, and you can also do graphing with a little bit more complicated way. But substitution and elimination are probably the 2 best methods on this. So let's go ahead and take a look. Okay, so we have 3 equations here. And the best thing I'm going to do is I'm going to try to get to whittle them down. So this is going to take a little bit of finagling. So I have 5x plus 3y equals -5z equals 3. So let's go ahead and get them down